Welcome back, students. We have already completed part 1 of the chapter Gravitation. Now we are moving on to the next part of the chapter Gravitation, that is about thrust and pressure. Okay. So have you seen trucks? Have you imagined trucks with thin tires? It looks odd, doesn't it? So trucks need wide tires in order to manage the heavy load that is carrying. Okay, it needs wide tires, then only it will be able to manage the heavy load on it. Now just observe a homemaker who is chopping vegetables. Will she use a blunt knife to chop the vegetables? Will she success in it if she uses a blunt knife to chop vegetables? No. She needs a sharp edged knife to chop vegetables easily. Okay. So what is the significance of this wide tires of trucks and the sharp edges of knife? To understand this clearly, we should learn about the concept of thrust and pressure in detail. Okay. Now this truck needs wide tires in order to minimize the pressure given by the load, and the housewife need a sharp edged knife to chop the vegetable easily, so that the pressure will be more, so that she will be able to easily cut the vegetables. Now let us look how it is. Why pressure has to be maximized in certain situation, why pressure has to be minimized in certain situation, or how we can maximize or minimize this pressure. Okay. So in this topic or in this session, we are going to learn in detail about all these things. Now before we move on to this pressure part, we need to get acquainted with a term called thrust. So let us see what the thrust is. Thrust is nothing but the force itself. Thrust is force. The peculiarity is thrust is a perpendicular force. That is, if we have a surface and if we are applying a perpendicular force onto the surface, this is the force vector. The direction of force and the wall is perpendicular to each other, or in other words, the angle between the force vector and the surface to which we apply force is 90 degree. The angle between the surface and the force vector is 90 degree. Such a perpendicular force is known as thrust. So thrust is a perpendicular force acting onto a surface. Since thrust is same as force, the SI unit of thrust will be the SI unit of force, that is Newton, represented by the letter N. Okay, so this is the thrust is a perpendicular force acting onto a surface. For example, consider hammering a nail onto a wall. So if this is a wall, if you need to hammer a nail into the wall, you need to apply a force using a hammer, and you apply a horizontal force to it so that the nail will get pierced into the wall. So this is the force vector. This is the direction of force that you apply, and this is the wall. Again, the force vector and the wall will make an angle of 90 degree, and this force that we apply is known as thrust, and its unit is Newton. Okay, and we have seen these nails have pointed ends, and the knives that we have discussed earlier have sharp edges. What is the significance of these pointed ends of nail and sharp edges of knives? Why is it so? Why do nails have pointed ends? Why do these knives have sharp edges? It is because the force that we apply to drive the nail into the wall, or the force that we apply to chop the vegetables will be translated into pressure depending upon the surface area onto which the force is being applied. Now, in other words, we can say that pressure is the force or the thrust acting per unit area. Suppose if you are applying a force onto this object, this whole object can be divided into areas of squares of side 1 meter. Suppose if this is the object, and if I divide this object into squares of side 1 meter, the area of the small square is 1 meter square, and the force experienced by this small portion of area is known as pressure. Okay. So, if I apply a force onto an object, the force experienced by a unit area portion of that object is known as pressure. That is, if I divide the whole object into squares of side 1 meter, the force that is experienced by the small portion, of the object is known as pressure. That is, pressure is the thrust acting per unit area. So, we can write pressure as it is thrust or the force acting per unit area. So, P is equal to thrust by area. This is the formula to find pressure. It is the force that is experienced by a unit portion of an object, a unit area of an object. It is a force experienced by a unit area of an object is known as pressure, and we know that the SI unit of thrust is Newton by SI unit of area is meter square. So, SI unit of pressure is either you can write Newton per meter square, or you can go for the unit Pascal, represented by the letter PA. So, the SI units of pressure is Newton per meter square or Pascal. Okay. So, thrust means it is a perpendicular force acting on a surface. That is, the surface and the force vector should make an angle of 90 degree. In such a case, that force is particularly known as thrust. And the thrust acting per unit area, the thrust experienced by a unit area of an object is known as pressure, and the formula to find pressure is thrust by area, and the unit of pressure is Newton per meter square or Pascal. Okay. Now, just see this equation. We have pressure is equal to thrust by area. Okay. Now, pressure is in the numerator part and area is in the denominator part. That means pressure and area are in inverse proportion. Pressure is in the numerator part and area is in the denominator part, means pressure and area are in inverse proportion. Inverse proportion means if area increases, pressure will get decreased. This is the meaning of inverse proportion. If area increases, pressure will get decreases. If area decreases, pressure will be increased. Opposite action. That is the meaning of inverse proportion. Okay. Now it will be clear why the nails have pointed tips. Now you may be able to answer it. Based on this concept, you may be able to answer why nails have pointed tips. Nails are having pointed tips means the area will be minimized. Because of the pointed tip, area is minimized. So, area of contact If this is a wall and if this is a nail, since they are having pointed tip, area of contact is less. Area of contact is less. When area of contact is less, pressure will be maximized. So it experiences maximum pressure, which help us to drive them easily into the wall. Now, why do knives have sharp edges? Again, sharp edges will minimize area, which in turn maximizes the pressure, which in turn increases the pressure. So, this increased pressure help us to chop vegetables very easily. Okay. So, you can expect many application questions based on these points as the inverse proportion of pressure and area. For example, why do camels have broad feet? We know that camel is an animal which walk through desert sand. Since they have broad feet, area of contact will be more. Since they are having a broad feet, area will be more. So, the pressure will be minimized. So, their legs won't get sink into the sand, so that they can easily walk through the sand. Now, the bags that we use have thin straps. The bags that we use have thin straps. It is because the thin straps will reduce, the bags that we use have thick straps than thin straps. Why? Because the thick straps will increase the area of contact. Rather than using thin strap bag, it is better to use a thick strap bag, because a thick strap will increase the area of contact, which will minimize the pressure on our shoulder. So, we can easily carry a load. Okay. Next example is big buildings have wide foundations. Big buildings have wide foundations, because wide foundation means area of contact is more, pressure will be less. So, it will be able to withstand the heaviness of the building. Now, it will be clear why trucks have wide tires. Again, area of contact is more, which will minimize the pressure. So, it can easily carry heavy, it will be able to manage the heavy load which is there on it. So, these are certain application questions based on pressure. So, the point to be remembered is, when area increases, pressure decreases, and when area decreases, pressure increases. Okay. Now, let us consider another example. Consider a form and two identical metal blocks A and B of masses 300 gram respectively. Both the metal block have mass 300 gram, and the length, breadth and thickness of the metal blocks are 30 centimeter, 20 centimeter and 10 centimeter respectively, and both are identical and both are kept on the form. The first metal block is kept vertically and the second metal block is kept horizontally, okay, on the form. Now, let us compare the compression of form where A and B are placed. And we can see that the form shows more compression where metal block A is placed. Why do you think there is a difference in compression? We have already told that both the blocks are identical, both have same masses and same dimensions, that is length, breadth and heights are the same. But the compression at A, the compression of form where the block A is kept is more compared to than that of B, where B is kept. Why? Why do you see such a difference? It is because of the difference in pressure exerted by block A and block B. Even though both have same dimensions and same mass, block A is placed vertically and block B is placed horizontally. So, there will be due to the change in positions, there will be a difference in pressure, and this pressure difference will create a difference in compression. Now, let us see in detail. Consider block A. Okay, consider block A. The surface which is in contact, surface of block A which is in contact with the form is 20 centimeter and 10 centimeter. The edges 20 centimeter and 10 centimeter is in contact with the form. So, this is of block A. So, area of block A which is in contact is 20 into 10. Okay. So, the dimension which is of block, let us consider block A. The dimensions which are in contact with the form is 20 centimeter and 10 centimeter. And we know that the SI unit of length and breadth is meter. So, we need to convert centimeter into meters, that is 20 into 10 raised to minus 2 meters. To convert centimeter into meters, multiply with 10 raised to minus 2. Again 10 centimeter. To convert 10 centimeter into meters, again multiply with minus 2. So, length is 20 into 10 raised to minus 2 meters and breadth is 10 into 10 raised to minus 2 meters. Now, what is the area of contact? It is L into B. So, this portion of the block is in contact. This portion is in contact. So, that is base portion is in contact. Base portion, the dimension of base portion is 20 and 10. The base portion is in contact with the form. So, dimension is 20 and 10. And we converted into meters. To find area, formula is L into B, that is 20 into 10 raised to minus 2 into 10 into 10 raised to minus 2. Now, what is 20 into 10? 20 into 10, it is 200 into 10 raised to minus 2 into 10 raised to minus 2. According to law of exponents, a raised to m into a raised to n is a raised to m plus n. So, here we have 10 raised to minus 2 into 10 raised to minus 2, that is 10 raised to minus 2 plus minus 2, a raised to m plus n. M is minus 2, n is also minus 2. That is 200 into minus 2 plus minus 2 is 10 raised to minus 4, unit is meter square. So, this is the area of contact. This is the area of contact of block A. Now, in order to find pressure, formula is F by A. But in the question, force is not given. So, we know a formula to find force, that is mg by A. Pressure is F by A is also equal to mg by A. We already know that mass of the block given is 300 gram. Again, the SI unit of mass is kilogram. So, we need to convert this gram into kilogram. To convert gram into kilogram, multiply with 10 raised to minus 3. If we multiply with 10 raised to minus 3, the unit gram will change into kilogram. So, pressure is equal to mg by A, that is Mass is 300 into 10 raised to minus 3 kilogram into, let us take G as approximately 10 meter per second square. For easier calculation, let us consider G as 10 meter per second square. So, G is 10 divided by area of contact. Area of contact of block A, we got it as 200 into 10 raised to minus 4 meter square. So, area of contact, let us substitute as 200 into 10 raised to minus 4. On solving this, we will get the answer as 150 Newton per meter square or 150 Pascal. Okay. So, area of contact was 200 into 10 raised to minus 4 meter square and pressure we got as 150 Newton per meter square, and thrust obtained, thrust is equal to the force, that is mg. Force was equal to so much, it is 300 into 10 raised to minus 3 into 10. This is the force or the thrust obtained. Now consider block B. Consider block B. Now can you say which dimensions or which all sides are in contact with the form? Which all sides of block B are in contact with the form? It is placed horizontally. Since it is placed horizontally, this will be the side which is in contact with the form. So, the dimensions are 20 and 30. The dimensions in contact will be 20 and 30. That is, in order to convert centimeter into meters, we should multiply with 10 raised to minus 2 meters. Again, to convert centimeter into meters, 30 into 10 raised to minus 2 meters. Okay. Now, to find area of contact, formula is L into B, that is equal to 20 into 10 raised to minus 2 into 30 into 10 raised to minus 2. Now, multiply this 20 and 30. 20 into 30, that is 600 into 10 raised to minus 2 into 10 raised to minus 2. Again, you can use the exponent law. A raised to m into a raised to n is a raised to m plus n. That is 10 raised to minus 2 plus minus 2. That is 600 into 10 raised to minus 4 meter square. Okay. So, this is the area of contact. Now, to find pressure, formula is F by A. F is not given. So, substitute the formula to find F. F is equal to mg by area. Again, mass is 300 gram itself. Since it is an identical block, it is 300 gram itself. Again, to convert gram into kilogram, multiply with 10 raised to minus 3. So, to change gram into kilogram, multiply with 10 raised to minus 3. Okay. So, again take acceleration due to gravity as approximately equal to 10 meter per second square for easier calculation. That is 300 into 10 raised to minus 3 into 10 by area is 600 into 10 raised to minus 4. Now, on solving this, you will get the answer as pressure is equal to 50 Newton per meter square. Okay. So, when we do the calculation, let us compare the situations of block A and that of block B. For block A, area of contact was 200 into 10 raised to minus 4. 200 into 10 raised to minus 4. We got the pressure as 150 Newton per meter square, and we got thrust equals mg is equal to 300 into 10 raised to minus 3 into 10. Okay. Now for block B, area of contact when it was placed horizontally, area of contact was 600 meters square. We got the pressure value as 50 Newton per meter square, and thrust equal to mg is equal to 300 into 10 raised to minus 3 into 10. These are the findings based on the problem. Just see, here area was 200, pressure is 150. Here area is 600, pressure is 50. So compare the area of block A and block B. Area of block B is greater than area of block A. Block B is having an area of 600 meters square, while block A only has an area of 200. Now compare the pressure. Pressure of block A is more compared to the pressure of block B, because see, area of block A is less compared to block B. Since area and pressure are in inverse proportion, if area is less, pressure will be more. So pressure exerted by block A is more than block B. So from here, from this comparison, we can say that area of block A is less than area of block B. Hence, pressure exerted by block A will be more than pressure exerted by block B, since pressure and area are in inverse proportion. But just see the thrust value. 300 into 10 raised to minus 3 into 10 Newton. Here 300 into 10 raised to minus 3 into 10 Newton. In both the cases, thrust values are the same. That is that the thrust doesn't depend upon the position, it remains the same. But pressure depends upon the position of the object placed. When the block was placed vertically, it shows a high pressure, it exerted a high pressure than when the block is kept horizontally. So it depends upon the position of the object. Pressure depends upon the position of the object, while the thrust doesn't depend upon the position. Okay, thrust remains the same throughout, and you can, thrust is equivalent to the perpendicular force, and you can find thrust using the formula mg. And in order to find pressure, use the formula F by A. As area increases, pressure will decrease, as area decreases, pressure will increase. And when you do a problem, you need to convert all the units into the SI unit. Hope the portion are clear. Just now we have discussed about the pressure exerted by solids. Okay. The thrust and pressure are also applicable to other states of matter, that is liquid and gases too. And this liquid and gases are collectively known as fluids. Okay. Just like solids, fluids also have weight. And this weight of fluids will exert a force on the walls of the container and on the bottom part of the container. That means the fluids also exert pressure on objects just like solids. Hope the pressure and thrust topic is clear. Please do go through the problem too. Thank you.